Let's put on our senior architect hat for a minute. We're going to walk through the exact security review process I use for Google Cloud storage services. You know, the kind of review that has to happen before any new design gets that final, all-important sign-off. Okay, so picture this. A new architecture diagram lands on your desk. It's ready for production. People have checked it for performance, for cost, for scalability. It all looks great. But then, the last and, honestly, the most important question lands with you. Is it actually secure? Is it good enough to protect our data? That final sign-off, well, that's a huge responsibility.
So, where do we even begin? For me, it's always at the front door. Before we look at encryption, before we look at networking, we have to know who has the keys to the kingdom. And in Google Cloud, that means taking a deep, hard look at identity and access management, or IAM.
And the first thing that just jumps right off the page, this is the thing my eyes scan for immediately, is this giant red flag. A cloud storage bucket that's configured to be publicly accessible to the entire internet. This is easily one of the most common and most dangerous misconfigurations you can find, and it is an immediate showstopper in any review I do. Full stop.
Thankfully, the fix here is pretty straightforward, and this is where a real lifesaver of a feature comes in. It's called Uniform Bucket Level Access. See, by just enabling this one setting, you completely shut down those old, confusing access control lists, and you make sure that only your main IAM policies can grant access. It simplifies everything and makes it practically impossible to accidentally make a bucket public. This is the green flag I am always looking for.
Okay, so let's move on to the next really common IAM problem I see. You're looking at an application service account, and you see it has the storage.admin role. You've got to stop and ask yourself, does this little application really need the power to delete the entire bucket and all the data inside it? The answer is almost certainly no. It probably just needs to read some files, maybe write a few.
And this brings me to a crucial point, and I want to be really clear about this. The principle of least privilege is not a suggestion. It's a hard rule. It's non-negotiable. I will never, ever approve a design that gives some automated service administrative-level permissions. We always dial it back to the absolute minimum set of permissions it needs to do its job, and not one permission more.
Okay, so we've secured the front door. Our IAM's looking good, but what about the actual valuables inside the vault, right? I mean, what happens if an attacker finds some other way in? That brings us to our second major check, protecting the data itself when it's just sitting there with strong encryption.
Now, the gold standard for this is something called Customer Managed Encryption Keys, or CMAC. And what's really interesting here is the shift in control. Instead of just letting Google manage all the keys that encrypt your data, you hold them, you control them. If you disable or destroy that key, the data it was protecting becomes completely inaccessible. It's just garbled bits. No one can read it, not even Google.
So let's just break this down. Look, by default, Google encrypts everything for you, which is fantastic. But for your really sensitive data, we're talking financial records, private health information, critical IP stored on persistent disks or in your storage buckets, using CMK gives you that ultimate layer of control. And for a lot of compliance rules, it's not a nice to have. It's a hard requirement.
Okay, so let's move on to our third check. We've locked the door with AIM, we've secured the loot inside with CMI. Now we need to inspect the actual walls of the building itself. We have to control the network perimeter to shrink that attack surface down as small as we possibly can.
And here is another classic red flag I see way too often. Someone deploying a sensitive service like Google Cloud File Store, which is basically just a managed network file share on the default VPC. Now, you got to understand, the default network is often this wide open space shared by tons of different projects. Putting your file server there, that's like putting your most secret file cabinet right in the middle of a public lobby. It just doesn't make sense.
So the proper way to handle this is with total network isolation. You put that file store instance in its own dedicated virtual private cloud. Then you use secure tools like Private Service Connect to let only specific, authorized applications talk to it. You lock everything else down with firewall rules, and you log every single connection attempt. We shrink that perimeter down to the absolute bare minimum.
All right, we've done it. We've inspected the doors, we've checked the vault, we've tested the walls, we've found the red flags, and we've put the right fixes in place. Now it is time to bring it all together into that final sign-off using a clear, non-negotiable checklist.
For me, it all comes down to this system, this exact checklist. Is uniform bucket level access turned on? Check. Are there any storage.admin roles on our service accounts? Absolutely not. Is the principle of least privilege applied everywhere? Yes.
Is our most sensitive data protected with CMEC? It has to be. Are our network services, like file store, properly isolated from the default network? Check. And finally, are we actually logging who is accessing our critical data? Yes. Only when every single one of these boxes is ticked does that design get my signature.
So we've done all our due diligence, right? The architecture is now secure, it's resilient, but here's the thing, the work is never really done. Security isn't some one-time project, it's a process that never stops. So the final question I always leave the team with is this. Now that our vault is fortified, what is our plan for monitoring it, for auditing it, and for making sure it stays secure when things inevitably change down the road? That's the real key to long-term safety.